Hey guys, welcome to Unit 7, Lesson 1. We're going to talk about these things called rational expressions in this particular lesson. And we're going to talk about, there's a lot of things you could do with them, of course, like any other type of function. But today we're going to be focusing on how to simplify them, multiply them, and divide them. So first of all, let's talk about what a rational expression is. A rational expression is the ratio of two polynomials. The word ratio is just a fancy word for fraction. Okay, so we have a polynomial. So for instance, we have like x squared minus 3, right? That's a polynomial. Well, if you make a fraction out of that with another polynomial, well, now you have what's called a rational expression. Okay, they can come in all different kinds. So like here's another example here. Have that. You could have this. There's just all kinds of rational expressions that you could possibly have. So basically, anytime you have a polynomial over another polynomial written as a fraction, you basically have what's known as a rational expression, and that's what this entire chapter is devoted to, which is our last chapter of semester 1. And so today we're going to learn how to simplify these expressions, and we're also going to learn how to multiply and divide them. So now we're going to talk about how do you simplify a rational expression first for the day. Well, let's go ahead and start. Let's start with something familiar, okay? You guys know how to simplify them already. Like, let's say I gave you guys 8 over 10. What would you do to simplify this expression? Well, you would just look to see what they have in common, and you would divide it out. So, for instance, both of those can be divided by 2, right? And that would give me 4/5. So, what do I mean by simplify a rational expression? It basically just means reduce. In this case, okay, it just means to simply reduce. Find out what they have in common and divide that common factor out. But we've also, this is just how to deal with, when you're dealing with numbers only, right? But what if you have variables? Well, let's say I had like x to the 3rd over x to the 7th. Now, the long way to go about this would be to realize that x to the 3rd means you have 3 x's being multiplied together, and x to the 7th means you have 7 x's being multiplied together. And what we do is we divide them out. X divided by x leaves 1. X divided by x leaves 1, x divided by x leaves 1, and so on the top we're left with 1, and on the bottom we're left with x to the 4th power. But there's definitely a faster way to go about doing this. What you do basically is you subtract your powers, right? So what's 7 minus 3? Well, it's 4. And since the bigger power was on the bottom, then the 4 x's are left over on the bottom. Okay, so likewise, now if we apply that shortcut, let's say I had x to the 10th over x to the 7th power. Well, we're going to subtract my powers, so that's going to be x to the 3rd, right? Because it's going to be 10 minus 7 is 3, so it's going to be x to the 3rd, but where does it go? Does it go on the top or the bottom? Well, since the bigger power was on the top, that's where the leftovers will be, so it'll be x to the 3rd. Now, you could put it over 1 if you want to, but you don't need to have a 1 on the bottom. So you can just write your answer like this. But if you ever end up having the big one on the top, then you should have a 1 on the top if there's nothing else, because otherwise you actually end up with a wrong answer. So don't need 1s on the bottom, but you do need 1s on the top if there's nothing else up there. Okay, so that's the basic idea. Now we're going to expand on that thought in a minute, because what we're dealing with here is what's known as monomials. So both of these are monomials. But when it's polynomials, it's going to be a little bit different. But for now, when it comes to numbers, just reduce like you're used to. When it comes to variables, we're going to use this process. And that's how we deal with monomials. Now, dealing with polynomials, multiple terms is going to be a little bit different. But for now, let's focus on monomials. Right? So, let's go ahead and do a teacher example number 1 here. We have 24a over 80a to the second power. So what we're going to do is we're going to reduce these coefficients like we normally would. What is 24? What can be divided into both 24 and into 80? And you want to find the biggest number you can. Okay? Well, I'm pretty sure 8 goes into both of those. So I'm going to divide both of them by 8. So that's going to give me, if I divide 24 by 8, I'm going to be left with 3. And if I divide 80 by 8, I'm going to be left with 10. But we also have our variables to concern ourselves with here. A to the first power and a squared. So what do we do with those? We subtract the powers. So 2 minus 1 is going to be 1. So it's going to be a to the first power. And where is that a to the first power going to go? Is it going to go on the top of the fraction or the bottom? Well, since the bigger one was on the bottom, it's going to go on the bottom. So here would be your final answer. All right? So reduce the coefficients like normal. And then for the variables, you subtract the exponents and put the final result in the numerator or the denominator, depending on where the biggest power was to begin with. All right, so let's go ahead and take a look at another one here. So my coefficients are 24 and 42. So what can I divide out of those two? What's the biggest thing I can? I'm pretty sure 6 goes into those. So I'm going to reduce those by 6. So if I divide the top by 6, 24 divided by 6 is 4, and 42 divided by 6 is 7. Now, if you do your reducing and you find out that, oh, it could be reduced some more, then that just means you didn't pick the biggest number possible. So you could either just reduce again, or you can start completely over and pick a bigger number to divide by. But either way, just make sure you reduce it down until you can't reduce anymore. 4 and 7 is as reduced as that's going to get. Now let's take a look at the a's. So we have a cubed over a squared. Well, once again, you're going to subtract those. So 3 minus 2 is 1, and it's going to go on the top. We don't really need to put the power of 1, but it's going to go on the top because the bigger power was on the top to begin with. Okay. So I've got a student practice here for you guys. Matter of fact, I think I've got 2 of them here for you. So why don't you guys go ahead and pause the video and see if you guys can simplify these expressions using what we've just discussed so far. So there's the answer number 3. Reducing 10 over 10 is 1 over 1. And 4 minus 2 is 2 for the exponent. So we have r squared. And we put it on the bottom because the bigger one is on the bottom. So we don't really need the coefficient of 1 in front of the r squared there, so we could just write r squared. So the final answer is 1 over r squared. Let's take a look at the next one. So for the coefficients 30 and 60, we can reduce by 30. 30 goes into itself once, and 30 goes into 60 twice, so we end up with 1 over 2. For the variables, x cubed over x squared, we subtract the powers. 3 minus 2 is 1, so we have x to the first power. And it goes on the top because the bigger power was on the top. And we don't need the coefficient of 1, and we don't need the power of 1. You don't need to write those when they are 1s. So we can just write x over 2 as our final answer there. All right. So we've talked about how to simplify rational expressions when they're monomials. Basically, you reduce the coefficients and you subtract the exponents, right? So I'm going to clean this up, and I'm going to make a little bit of a note about that now as a summary. So we have 2 situations I want you guys to be aware of. We have monomials, which is what we've talked about already. And when it comes to monomials, what you do is is you reduce the coefficients and you subtract exponents of variables. And the answer goes in the numerator or the denominator, depending on which one's bigger. But that's for monomials. Let's talk about polynomials, though, because when you're dealing with polynomials, it's a little bit more complicated. What we have to do is you can't really just look at it and think, well, what can I divide out of both of these, which is what we pretty much were doing with monomials. Because you can't really just look at a polynomial and know exactly what divides into a polynomial. But the way that you're going to know what divides into a polynomial is by factoring it. So the first thing we're going to do is we're going to factor the numerator and the denominator. After you've factored them, you will see what factors they have in common, and you can just divide those out. Now, I'm just going to say that briefly from now on as cancel. Okay, so that's basically what it's going to be. So when you're dealing with a polynomial, you need to factor first and cancel. So we have two different ways we're going to approach this. We have monomials, we have polynomials. For polynomials, reduce the coefficients, subtract the exponents. Boom. For polynomials, it's factor and cancel. All right. So let's go ahead and take a look at an example like that. So as you guys can see here, we have a polynomial now. It's not just one term on top of another term. It's an entire polynomial over another polynomial. A trinomial being divided by a binomial. All right, so what are we going to do? Well, as I said, we're going to factor, and then we're going to cancel. So let's start by factoring. Step one is to factor. Now, when you're factoring these things, you got to remember the rules for factoring. So how do you do that? Well, you start by looking for a GCF. If it has 3 terms, then we're going to use the box. If it has 2 terms, it might be a difference of squares. And that's pretty much the only kind of factoring we're going to be doing in this particular chapter. Okay, we're not going to get into the other fancy stuff that we talked about in Unit 6. So it'll be one of those 3. So first of all, taking a look at the top, do you guys see a GCF there? There's no GCF, so we could skip that. But it is a 3-termed polynomial, so we are going to use the box method for that. So I'm going to show my work here very small, but how do we factor it? Well, we put the first term here, we put the last term here, and we look for 2 things that multiply together to make those things. I know that either the 5 or the 9 have to be negative. And I know I'm right if these 2 terms add up to make the middle, and in this case they do. Negative 9 plus 5 does make negative 4. Okay, so the top factors into v minus 9 and v plus 5. The bottom, we're going to need to do a GCF here, so I can see that there's a GCF. I can see that both 4 and 20 can be divided by 4, and they both have at least 2 v's, so I could take out a v squared. So if I divide this by 4v squared, I'll be left with v. If I divide this by 4v squared, I'll be left with 5. Now, at this point, that's the first step. Step 1 is to factor the numerator and the denominator. So we've done that. The next thing that we're going to do is we're going to cancel out any factors that they have in common. Okay, so v plus 5 and v plus 5 will cancel each other out. And I'm going to be left with v minus 9 over 4v squared. All right, so why don't you guys go ahead and pause the video here. And I'm going to have, well, actually not yet, sorry. Pause the video here, and you guys go ahead and try to factor and cancel this. In other words, I want you guys to simplify this rational expression. The steps are factor and cancel. See how you do. All right, so there's your answer to that problem. You do the box on the top, which would give you m plus 7 times m plus 7. And on the bottom, you would take out a GCF, which would give you 3 times m plus 7. And then you can go ahead and cancel out what they have in common. All right. Now I want to talk to you guys about some rules about canceling out factors here really quick before we go any further. So let's go ahead and talk about this one. So first of all, a times b divided by a times c, you can cancel the a's out and get b over c. That's a happy situation, okay? This is not a happy situation. You can't cancel these a's out like that and get b over c. That's a no-no. You can't do that. And it's pretty easy to kind of, so first of all, there's two ways I can have you guys remember this, you know. One is that when you're canceling these things out, you're dividing, right? So a divides into a to make 1, right? Well, division cancels multiplication, correct? Because they're opposites. But division doesn't cancel addition. That doesn't make sense. So you can't do that. Another way is you could just, to test your theory, you know, you could just plug numbers in. You know, you could say let a equal 2 and b equal 3, for instance. And pick another number for c. That's the same thing as 3 over 4. And you could prove that because 6 over 8 does reduce to make 3/4. But if you plugged in 2 and 3 for this expression, you end up with 5 over 6. But that's not the same thing as if you just cancel those out. 3/4 is not equal to 5/6, right? You can't do that. So that's another way you guys can look at it and remember it. But I would say that the most common mistake that I see students making here, just to give you guys a quick little example, is the fact, here's an example of what students will do quite a bit here. So like, let's say we have x plus 5 over x minus 3. Well, you can't do this. You can't cross those x's off and get 5 over negative 3. That's a no-no. Okay, you can't do that. So just be aware of that situation. All right. Now, an example of a positive situation, something you actually can do, is if you had this. This can cancel this. Why? Because x minus 3 is being multiplied by something. And so if you divide x minus 3, the division of x minus 3 cancels the multiplication of x minus 3. So that's allowed. That's a happy situation. Division cancels multiplication. It doesn't cancel subtraction or addition. Okay. Here's another situation to consider. If we can just continue to look at a few examples of canceling rules here. So if I have this, okay, you can't cancel anything here. This, even though it's being multiplied by x plus 5, can't cancel this. And the reason why is because this x, even though it's being multiplied by the 3, it's also being subtracted by 2. So you can't do that. That's a no-no. That's a sad situation. Not allowed to do that. However, here's something you would be allowed to do. Now you can cancel out the x because this x is being multiplied by something, and this x is only multiplying things. So in that case, it can. Anytime a variable is connected to a number or another variable by addition or subtraction, then it becomes united to it. It becomes like one piece. So you can't take any piece of this thing separately from the others, but these x's do cancel. And so in this case, you have x plus 5 over 3 times x minus 2. That works. That's allowed. Okay? So basically, anytime your variable is connected to a number or another variable by addition or subtraction, it becomes united with it. Okay? So you don't need to write this, but if you have an x that's standing alone by itself, it can cancel with something. But as soon as you add it to another number, it becomes one thing with that object. And so the only way you can cancel that x out now is if you cancel the x and the 7 at the same time. Okay? So that's kind of the idea there. All right? So just some rules about canceling that I want you guys to keep in mind. Now, here's another rule about canceling that I want you guys to be aware of. Follow with me here for a second. Suppose I said 5 plus 3. What does 5 plus 3 equal? You don't need to write this, by the way. I'll tell you what to write in a second, but for now, just watch. What's 5 plus 3? Well, it's 8. What's 3 plus 5? Oh, well, that's also 8, right? So 5 plus 3 over 3 plus 5 gives you the same thing over the same thing. They're identical, and so you end up with 1, right? And so what we can do is if you ever have a situation where you have x plus y over y plus x, you know, these can just cancel each other out and it leaves you with 1. Okay, that's fine. But think of this now. 5 minus 3 over 3 minus 5. Well, 5 minus 3 is 2. And 3 minus 5 is negative 2. Those are not the same thing. Now, you could still divide these and still get 1, but it's not going to be 1, right? It's going to be negative 1, correct? And so here's where I would like you guys to write, because this is significant for what we're doing. If you have x plus y over y plus x, they just cancel, okay? You could say it equals 1 if you want to, because they literally are identical and they can divide each other out. But if you ever have x minus y over y minus x, what we're going to do is we're going to say, okay, go ahead and cancel them, but it doesn't make 1, it makes negative 1, okay? So we can still reduce them, but if you reduce them, you have to know that it's going to create a negative factor as a result. So knowing that, we're ready to jump into another topic now, which is multiplying rational expressions. How do we, because we talked about, you know, rational expressions, what they are. We talked about how to reduce them with monomials. We talked about how to simplify them with polynomials. But now I want to move into talking about multiplying and dividing these things. So let's start with multiplication. How do you multiply a rational expression? Well, the good news is the steps are exactly the same as they are for reducing. All you do is you factor and you cancel. That's it. The reason that the steps are actually the same thing is because when you have two fractions, like say 2 over 3 times 6 over 10, right? Well, when you multiply, don't you just multiply the top times the top and the bottom times the bottom? So really, when you're multiplying two fractions together, it's really like you have just one giant fraction that's with two pieces being multiplied together. So you're just going to treat it basically the same way you would treat a single fraction, which is by factoring and canceling. So to kind of carry this example out some more, you could factor the 6, you could factor the 10, and then you can cancel out what they have in common. All right. Or you could do it the old school way, which is get 12 over 30 and reduce that the way you're used to. But either way, the point is that you can just factor and cancel. The only thing that's interesting is that since they become one fraction, then basically something from this fraction can cancel something from the other one. Okay, and so that's kind of how these ones work. So let's take a look at it. But it's basically the same thing as the last set that we looked at. It's factoring and canceling. So the first thing I'm going to do is I'm going to put all these things together in one fraction. Now, you don't have to do this step, and in the future, I actually just may not. But when you multiply fractions, right, you just do top times top and bottom times bottom. Now, I'm not actually going to multiply them out because that would kind of be the opposite of what I want to be doing right now. I actually want to break it apart even more and cancel out what they have in common. So, can I factor anything here? Well, this is not factorable. There's no GCF, and it's not a difference of squares. Same thing for these. Neither one of those are factorable, nor they're not difference of squares, and they don't have GCFs. But this guy right here can be factored. That's a difference of squares. So we're going to do the difference of squares on that. Now, if you forgot how to do the difference of squares, I will review that with you now. But step 1 is to factor. If you want to do step 1 like I did where you put them together into one fraction, you can. But I'm not going to count that as a step. I'm just going to do that now because I might not do it in the future. I'm just going to say factor. Okay, so this is a difference of squares. How do you do difference of squares? You take the square root of the first term, which is x. You take the square root of the last term, which is 1. You're going to write that twice. For one of them, you're going to make it a plus. The other one, you're going to make it a minus. So that's difference of squares. Okay, and true to form, what I told you, the 2 steps for multiplying is going to be factor and then cancel. So I factored, and now I'm going to cancel what's left. So let's see what's the same on the top and bottom. X plus 1 can cancel with x plus 1. They're identical, so when you divide them out, you're left with 1, so we're done. But there's another one that's pretty close. We have x minus 3 and 3 minus x. They're not really the same, though, right? We talked about that. They're opposites. So what we can do is I can cancel these, but if you cancel these ones out, you have to put a negative in there because it actually makes a negative 1. So we're going to put a negative in the front, and it's going to be x minus 1 over nothing, actually. You could put a 1 down there if you want to, but there's nothing left on the bottom. So what I want you guys to walk away from here understand is that I canceled these, but because I canceled those things and they're opposites, we had to put a negative there in the front. Now you can write your answer like this, but I think another way, a better way to write your answer would be like this, because we don't really need the 1 in the denominator. Or we can actually go the extra mile and distribute the negative in and get negative x plus 1. Or a lot of times whenever you have an expression like this, they'll put the positive 1 in the front and the negative x after it. So either one of these are all good answers. I don't think you'll see this as an answer, though. So I'm just going to cross, I won't cross it off, but I won't put a box on it. But this is how the answer will look probably on your multiple choice, one of these 3 options. My guess is it's probably the top one most of the time because I know how my software works. But I wouldn't be surprised if sometimes it did one of these 2 things. So you might have to distribute the negative in. Sometimes they might reverse the order as a result of that. But there's the idea. All right, so let's take a look at student practice 3. So I want you guys to pause the video here and see if you guys can work this one out. The final answer there is in the box. So the first thing I do is I just put it together as one giant fraction. The next thing that we can do is this is a difference of squares, which would turn into this. And then we have this, which is a box method, which would be this. And then if we just start canceling some stuff out, this n plus 3 can cancel out this n plus 3. And I'm allowed to cancel out the n minus 5 and the 5 minus n if I put a negative in the front. And so I'm left with an n minus 3 on the top and an n plus 3 and a negative. On the bottom, there's nothing left, so you could put over 1 if you want to, or you could just leave it like this. And that would be good enough for this problem. Now, there's a lot of ways you could write this. You know, you could multiply these together. It's a shortcut that we learned earlier, right? First times first, last times last. And then you could distribute the negative, and then they might even reverse it. But I'm fairly certain, I know this one for sure on my test, the way that they're written, it's going to be like that. They're not going to make you go through the multiplication process also. But there you have it. So that's student practice 3. Let's go ahead and move on to a new one. So now we're going to talk about how you divide rational expressions. Well, you don't need to write this, but just pay attention with me for a second here. How do you divide fractions? Well, what you hopefully remember from grade school is that you do same, change, and flip. After that, it's a multiplication problem. So since it becomes a multiplication problem after that first step, then we can just follow the same steps we did for multiplying as we did for rationalizing. We can follow the same steps we did for multiplying as we will for dividing. So let's go ahead and write out our steps here. So the first thing we're going to do is we're going to do same, change, flip. After that, it becomes a multiplication problem, so we stick to the same steps as we have for multiplication, which is factor and cancel. Okay, so that's how you divide rational expressions. Let's go ahead and take a look at an example like that now. So here's this. Every once in a while, you'll see a situation like this where one of the expressions is not a fraction. But it's kind of an easy fix. To make it a fraction, all you need to do is put it over 1. And now we can just treat it like any other one. All right, so step 1. What is step 1? Step 1 is same, change, flip. Okay, so we leave the first fraction the same. We change the division into multiplication, and we flip the second fraction over. Okay? After that, we're going to factor, and then we're going to cancel. All right? So let's factor the top. That's a GCF problem there. Both of those things can be divided by a 3 and a b. The bottom doesn't factor. It's got no GCF, and it doesn't have and it's not a difference of squares either. Of course, we can't do anything with the number 1. That just stays the same also. But the bottom right there, that could be factored. Both of those could be divided by a 9b. And a b plus 4, right? All right. So we factor now, right? Step 2. So same, change, flip, factor, and now we can go ahead and start canceling some stuff off. So like the b plus 9 here and the b plus 9, those go away. Now at the moment I don't see anything else, so that would give us this, but we can actually go a little further. So I'll show you what I mean in just a second here. Okay, well now this problem has a little something else that we can do. We get to reduce some more, actually. In this case, look at my monomials. I have a monomial of 3b on the top and 9b on the bottom. So how do we reduce monomials? we reduce the coefficients. So if I divide those by 3, I'm going to be left with 1 over 3. And as for these, the b over the b, those are just going to cancel each other out. 1 minus 1 is 0, so you're left with b to the 0 power, which is 1, so you have nothing there. And on the bottom, we still have the b plus 4 being there, right? So there it is. So this will be your final answer, 1 over 3 times b plus 4. So anytime you have a situation where you take out a monomial or take out a GCF, it's possible that you may end up having to reduce the monomials using the strategies that we talked about in our first 2 examples today. So don't forget to reduce your monomials. Okay, and there's our final answer for that one. All right. Here's one for you guys. Go ahead and pause the video here and see what you guys can do. Okay, the final answer is there in the top right, x plus 7 or x plus 2. First thing I did was I put this over 1. The next thing I did was I did same change flip. And then I factored out the denominator there. The denominator here, you could take out a GCF of 2x squared. And if you take out a GCF of 2x squared, this is what you get. Finally, we can reduce these 2 monomials out completely, which leaves us in the numerator with only having an x plus 7, and in the denominator an x plus 2. The 1 doesn't really do anything because you're multiplying by 1, and so there's our final answer for that. All right, so that concludes our lesson for the day. We learned what a rational expression is, how to simplify them if they're monomials, how to simplify them if they're polynomials, and then we also talked about how to simplify expressions that involve multiplication or division. All right, and so we'll see you guys next time.